Indosaw is India's one of the largest manufacturing company in educational science lab equipments. It has a wide range of equipment for making science learning fun. We present here an experiment suitable for training in experimental physics, which illustrates the study of ray diagram and various optical phenomena. At first, we will look into the items provided with this experimental setup. The first item is a magnetic whiteboard along with a stand. One laser ray box along with the adapter is also provided. A beam selector is also given for either the selection of paraxial rays or the marginal rays. There will be 7 working sheets. These are A. Human eye model, B. Photo camera model, C. Galileo telescope model, D. Kepler's telescope model, E. Spherical aberration model, F. Hartle's circle, G. Periscope model. Other optical components which are provided with this experiment kit are 4 biconvex lenses, 1 biconcave lens, 1 plane mirror, 1 concave mirror, 1 convex mirror, 1 prism, 2 rectangular plates, 2 plano-convex lenses, and 1 plano-concave lens. Using this kit, we can study the model of human eye, the principles of photographic cameras, Galilean telescope, Keplerian telescope, the phenomenon of spherical aberration, and its remedy, and the principle of periscope. Take the magnetic board and mount the stand in the slot provided at the back side of the magnetic board. Now mount the board vertically in the table, as shown. Place the working sheet labeled A on the magnetic board. Place the laser ray box on the magnetic board, as shown. Connect the adapter to the laser ray box. Switch on the laser ray box. The parallel rays will be emitted from the laser ray box. Place the beam selector in front of the laser ray box, in such a way so that only the paraxial rays pass through. Now place the biconvex lens number 1 behind line O to the paraxial rays will now focus to the retina. This illustrates the working of a normal eye. Replace the biconvex lens labeled as number 1 by the biconvex lens labeled as number 2. The rays will now focus short of the retina. This illustrates myopia. Myopia could be rectified by placing a concave lens in front of the eye. Place the biconcave lens labeled as number 5 near line O1 at a suitable position so that the paraxial rays focus at the retina. Replace the biconvex lens labeled as number 2 by the biconvex lens labeled as number 3. Also remove the biconcave lens labeled as number 5. The rays will now focus behind the retina. This illustrates farsightedness. Farsightedness is rectified by placing a convex lens in front of the eye. Place the biconvex lens labeled as number 4 near line O1 at a suitable position so that the paraxial rays focus at the retina. In a similar manner, you can also study the working principle of photocamera. Working sheet C enables us to study the principle of Galilean telescope. Working sheet D enables us to study the principle of Keplerian telescope. Arrange the setup with laser ray box, plano-convex lens which is labeled as number 14 and worksheet E, as shown. The paraxial rays and the marginal rays will meet at different points on the principal axis. This phenomenon is known as spherical aberration. Place the plano-concave lens labeled as number 13 adjacent to plano-convex lens labeled as number 14 to rectify the spherical aberration. All the rays now converge to a single point. A combination of laser ray box, a pair of plane mirrors and worksheet G allowed us study the principle of periscope. Thank you for watching us. Please stay with us at www.indosawedu.com.